Welcome again to one of the most enthralling, exciting, entertaining and enlightening session of Science Scamper for classes 6 to 8 by EduCatUp. And I am your super science teacher Ambika. At EduCatUp, we always empower all our students as how to think and not what to think. So if you want to experience the same, this is the right time. Subscribe to the EduCatUp YouTube channel. The subscription button is given below. If you like our video, don't forget to press the like button and ensure to hit the bell icon to get all the latest updates from EduCatUp. Now let's start today's session, and the topic for the day is fun with magnets. Something which attracts, something which grips the things. So today we are going to study about magnets, like how they work, what are their properties, everything. So let's start today's fun class with magnets. In this module, we are going to cover the following topics. What is a magnet? Discovery of a magnet, magnetic and non-magnetic materials, poles of a magnet, properties of a magnet, magnetic compass, uses of a magnet, demagnetization, and last but not the least, how to store a permanent magnet. Now let's move ahead. What is a magnet? If we ask ourselves that what is a magnet, the answer definitely comes that something which attracts other objects. Now for example, if some pins are scattered on the floor, definitely you find it very difficult to pick them up. I'm talking about the all pins through which we pin up the papers. So we really find it difficult to pick it one by one. But if we have a small piece of magnet, with the help of that, we can collect them in a very fast manner, plus in a very convenient and easy manner. That is the use of a magnet, and that is the quality of a magnet. You must have seen a lot of magnetic buttons and stickers available these days to put up on the refrigerators, almirahs, cupboards. What are they? You put them and they stick over the surface. What is that? A magnetic effect. So magnets have the property. So any object or a material that has the unique property to attract iron and some other materials. Now what those other materials are? Metals basically. To attract iron and other metals, those substances which have this property are known as magnets. Now the property of a magnet which allows it to attract other substances is known as the attractive property. भाई जिस property के through magnet दूसरे substances को attract कर पाता है, that property is known as attractive property of magnet. Now let's move ahead. Discovery of magnet. How we get this magnet which we are using so much these days. How we get to know about it. Let's find out. In Magnesia, in ancient Greece, there lived a shepherd named Magnus. One day he was looking after his sheep in the hills. All of a sudden, he felt a mysterious force pulling his iron staff from his hand. He was just taking his sheep for a round and he was having an iron staff to, tame his sheep. And suddenly what he felt that his iron staff is being pulled by something. Even the iron nails on his sandals were being pulled out. जो कीलें लगी होती हैं शूज पे लोग लगवाते हैं, those were also being pulled out by something. कोई चीज़ उसके उस आयरन के रॉड को, स्टिक को और उसके शूज में जो नेल्स लगे थे उनको अट्रैक्ट करके खींच रही थी, pulling towards that itself. Now then what happened? To his great surprise, he discovered that it was a huge black rock next to him that was pulling his staff and the nails. When he got to realize that what is pulling all these things, what he got to know, it's a big black colored rock which is actually attracting all the things. And actually what was happening? Magnetism. So that rock was actually containing some magnetic material, and that rock was named as magnetite, maybe on the name of this boy Magnus. So that is how magnetic material or magnetic substance of first magnet was discovered. And then later on, with a lot of advancement, with a lot of technology, today we have the kind of magnets that we are using. Now There are two types of materials, magnetic materials and non-magnetic materials. Now, magnetic materials are those materials which have the property or the quality to attract other materials or substances towards it. For example, you can see metals like nickel, cobalt, steel, iron, steel paperclip, all metals. These are all metals. So basically metals have this magnetic property, almost all the metals have this magnetic property of attracting substances towards them. And that is why they are known as magnetic substances. Now the substances which are not attracted towards a magnet, the substances which cannot be attracted towards a magnet are known as non-magnetic materials or substances. The examples can be paper, glass, plastic, rubber, wood. अगर एक मैग्नेट रखा हुआ है और उसके पास एक प्लास्टिक का कोई ऑब्जेक्ट रखा है तो मैग्नेट और वो प्लास्टिक आपस में स्टिक नहीं होंगे, वो आपस में अट्रैक्ट नहीं होंगे. Why? Because plastic is a non-magnetic material जो मैग्नेट की तरफ अट्रैक्ट नहीं हो सकता. वहीं अगर एक कॉपर का कॉइन रखा है और एक मैग्नेट पीस रखा है तो कॉपर का कॉइन और मैग्नेट एक दूसरे से अटैच हो जाएंगे जैसे ही पास में आएंगे. बिकॉज कॉपर इज अ मैग्नेटिक मटीरियल, इट गेट्स अट्रैक्टेड टूवर्ड्स अ magnet. So that is how we differentiate between a magnetic and a non-magnetic material. Now, poles of a magnet. The maximum strength or the maximum energy of a magnet is present at its poles. Now, poles means the two ends. Like for example, in this case, this is a horseshoe magnet. So, these are the poles, the ends. This is a normal magnet, rod shaped, bar magnet. So, these are the poles. The ends of a magnet are known as its poles. And the maximum strength, सबसे ज़्यादा जो magnetic power होती है, सबसे ज़्यादा जो magnetic strength होती है, वो इन्हीं ends पे मौजूद होती है. तो सबसे ज़्यादा strength यहीं पे feel होगी. सबसे ज़्यादा magnetism can be felt on these points, not on these areas. The pole which is facing towards the north direction is known as North Pole, and the pole which is facing towards the south direction is known as South Pole. In every magnet, you have North Pole and South Pole. Okay? Now, properties of a magnet. Now, the first property is like poles repel, unlike poles attract. Now, this is something we have heard from our childhood, and even today you all must be hearing it, like that if two people are similar, they will not like each other or they will not go together, and if they are opposite, they will definitely can be friends. Even you people think so. Your friends must be opposite to you. They must have a different quality, different kind of behavior. There is something which you can learn from them, and there is something which they can learn from you. The similar thing goes in our magnets also. So this property means that, let's understand. See, if the two poles are opposite to each other, that means if one magnet is having north pole and the other magnet's south pole is kept towards it, so the opposite poles are kept, so they will attract each other. एक दूसरे के पास आएंगे, एक दूसरे को attract करेंगे, एक दूसरे को खींचेंगे अपनी तरफ. अगर opposite poles हैं तो. अगर same poles रखे हैं like north and south और south, तो वो एक दूसरे को रेपेल करेंगे मतलब एक दूसरे से दूर जाएंगे, एक दूसरे से डिस्टेंस पे रहेंगे. सो व्हाट यू आर अंडरस्टैंडिंग विद दिस? सी, पहले वाले केस में जहाँ पे अट्रैक्ट करने का है वहाँ दो पॉसिबिलिटीज हो सकती हैं. आपको नहीं पता, देयर इज अ पीस केप्ट A and B. All right. Now they both are attracting each other. Now you don't know that which is a magnetic substance and which is a magnet. Now maybe this is a magnet with north pole and south pole, and maybe this is a magnetic material. This can also be the case of attraction कि एक मैग्नेट है और दूसरा मैग्नेटिक मटेरियल है. एनी मेटल लाइक आयरन, कॉपर, कोबाल्ट. तो मैग्नेटिक मटेरियल जो है वो भी मैग्नेट की तरफ ही अट्रैक्ट होता है. दूसरा केस क्या हो सकता है कि there is a piece A and there is a piece B. Both are magnets. North pole, south pole, north pole, south pole. दोनों का नॉर्थ सेम आ रहा है और रिवर्स कर दें अगर तो यहाँ पे साउथ हो गया, यहाँ पे नॉर्थ हो गया, तो ये दोनों फिर एक दूसरे को अट्रैक्ट करने लगेंगे. लेकिन क्या आप अट्रैक्शन के केस में ये बता सकते हैं कि अगर टू ऑब्जेक्ट्स आर केप्ट अननोइंगली, आप नहीं जानते कि जो दो पीसेस रखे गए हैं वो क्या हैं, कैन यू टेल दैट बोथ आर मैग्नेट्स? कैन यू से दैट? नो, यू कांट. बिकॉज अट्रैक्शन के केस में दो मैग्नेट्स अपोजिट पोल्स के संग एक दूसरे को अट्रैक्ट करते हैं एंड वन मैग्नेट एंड द अदर मैग्नेटिक मटीरियल ऑल्सो शोज अट्रैक्शन. So attraction doesn't tells you that whether the placed object is which one is magnet. But in case of repulsion, repulsion is always shown between only two magnets. Repulsion सिर्फ दो magnets के बीच ही होगा. देखिए अगर नॉन मैग्नेटिक सब्सटेंस होगा तो कुछ होगा ही नहीं, लेकिन रिपल्शन यानी एक दूसरे से दूर जाना, एक दूसरे से डिस्टेंस पे जाना, एक दूसरे के पास ना आना, दैट रिपल्शन विल टेक प्लेस ओनली इन केस ऑफ टू मैग्नेट्स एंड व्हेन दे आर फेसिंग द सेम पोल्स. So that is why repulsion is the sure test of magnetism. If repulsion is happening, then the two pieces or the two objects kept in front of you are magnets. So that is something you have to remember, that attraction, not repulsion, is the sure test of magnetism. अगर repulsion हो रहा है तो दोनों objects क्या हैं? Magnets हैं. All right. Now let's move ahead. Okay. The next is poles exist in pairs. Very true. You cut a magnet into as many pieces as you want. Suppose, as given in the picture, you have this bar magnet. Sorry. You have this bar magnet. You have cut it into 1, then 2, then 3. You can cut it into even more pieces. आप जितने pieces में चाहें किसी भी magnet को cut कर दीजिए. Even if you make such a small piece, it will have two poles, north and south. Poles always exist in pairs. यानी कि मैग्नेट का कोई भी पीस किसी भी साइज का हो उसमें नॉर्थ पोल और साउथ पोल दोनों हमेशा होंगे. यू कांट सेपरेट नॉर्थ पोल एंड साउथ पोल. इट कांट हैपन दैट अ पीस ऑफ मैग्नेट इज ओनली हैविंग नॉर्थ पोल और साउथ पोल. नो, it's not possible. If there is a magnet, there will be north pole, there will be south pole. Poles always exist in pairs. North and south दोनों होंगे. All right. Now let's move ahead. Attractive property of a magnet. The property by which magnet attract some substances like cobalt, nickel, iron, जो उसके पास लाए जाते हैं और जिन्हें वो अट्रैक्ट करता है, that property is known as the attractive property. We have discussed this in the beginning of the module also. So you can see in the image, this is a horseshoe magnet and there are these iron nails or the pins which are kept and they are being attracted. Even you must have seen a pin holder. It's a cylindrical pin. There comes a cylindrical pin holder in which the pins are attached at the mouth of it because of the magnetism and one can easily pick it out. So that is also a kind of the example of a magnet. Next is directive property of a magnet. Now, what does it shows? When a magnet is suspended freely, it always rests in north-south direction. The direction seeking behavior of a magnet is known as its directive property. What does this mean? As you can see in the picture, there is a stand. On the stand, with the help of a thread, a bar magnet is tied up. Now, obviously, initially it will move a little bit, but finally it will come to rest. When it will come to rest, actually it will be pointing in which direction? वो जिस भी condition में rest पे आता है, ऐसे, like this, like this, like this, in whichever way it comes to rest, actually it will be pointing in which two directions? North and south. Always. Always. वो जब भी रेस्ट पे आएगा, कोई भी मैग्नेट हो, आप उसको कितना भी हैंग करके you are swinging it, but finally when it will come to rest, it will point in north and south. So this property of magnet of always coming to rest in a north-south direction is called the directive property of a magnet. And how we will see that what is the use of this property? This property is used in a very particular way in a device which is known as magnetic compass. Now, what is a magnetic compass? Let's understand. A magnetic compass is a small box with a glass cover. It's a small circular box with a glass cover so that you can see the internal readings and the needle in it. It has a magnetic needle in the center, and on the magnetic needle, north and south are marked. On the dial also, that means on the surface of the glass box, north, south direction and east, west, all the 4 directions are mentioned. Now, if you have to find the direction, that suppose I am standing here and I need to find the direction north, south, that which direction is north and which direction is south. So for that, a magnetic compass is used. What you have to do, you have to just put it on the floor and wait for the needle to come on the rest. Let the needle come to rest. See, I'll explain you. See, suppose this is your magnetic compass. It's written north, south, east, west. This is your needle. On it, it's written north and south. Now you need to, this is your magnetic compass. Now you need to find the direction at any point. What you will do, you will put the magnetic compass on the floor. Let the needle come to rest. If needle comes to rest, like this, maybe for example, essay. It has come to rest like this. That means this needle is pointing according to the dial surface in east-west. Pick it up, again rotate it and again keep it. You have to wait till the time that the needle should point in the direction of this north and south. That means your compass should have its needle like this. The needle's north and the needle's south should be pointing towards the dial's north and dial's south. जो कंपास का सरफेस है, जो उसका डायल है, उस पे जो नॉर्थ और साउथ डायरेक्शन है, आपकी नीडल के नॉर्थ और साउथ को भी उसी तरफ पॉइंट करना है. और जब तक वो पॉइंट नहीं कर रही है, यू हैव टू कीप ऑन रोटेटिंग इट एंड कीप ऑन चेंजिंग द डायरेक्शंस. कभी फ्रंट में रखा, कभी बैक में रखा, कभी लेफ्ट साइड, कभी राइट साइड. यू हैव टू डू इट लाइक दैट. एंड वंस द नीडल इज pointing towards the north south में आ गया, बस वही आपका north south है, and you will get to know. So that is how a magnetic compass works. And magnetic compass uses the directive property of magnet, which is like that whenever a magnet comes to rest, it always points in north south direction. Let's move ahead. Action-packed info, guys. Something very interesting and very enlightening for you, so pay attention. It's something related even to your geography part. The geographic North Pole and magnetic North Pole of the Earth are not in the same place. You know that Earth has its own magnetic field. Earth का अपना खुद का magnetism होता है, खुद की magnetic field होती है. अर्थ का जो नॉर्थ पोल एंड साउथ पोल है, जो जोग्राफिक नॉर्थ पोल एंड साउथ पोल है, और जो मैग्नेटिक नॉर्थ पोल एंड साउथ पोल है, दे आर नॉट एट द सेम लोकेशन. दे आर अ लिटिल deviated from each other. Even recent studies have shown that the magnetic North Pole and South Pole of the Earth are shifting because of the movement of molten iron in the Earth's crust. So that is altogether a different thing, but you should know this, that the magnetic North Pole and geographic North Pole are not same. They are a little deviated. एक दूसरे से थोड़े से distance पे होते हैं. Alright, let's see ahead. Making magnets. How you can make magnets at home. Even you can make magnets at home. That is a method called single touch method. In single touch method, what you have to do, as it is shown in the picture, take an iron piece and take a magnet, a small bar magnet. Start rubbing the magnet on the iron surface from poles to the middle, from pole to pole. Start rubbing it. In some time, this iron will also acquire magnetism. This method is called single touch method. But this single touch method is not very strong because the magnet which will be formed will not last for a longer time. The magnetism, the strength will not be very stronger or very much will not last for longer. मतलब वो बहुत ज़्यादा देर तक आयरन का पीस मैग्नेटाइज्ड नहीं रहेगा इस मेथड से. So that is why nowadays electric current is used to get the magnets done, but at home for your own personal experiment you can definitely try out. There is no harm, no danger, and you must try out, children, because you should see the fun with magnets. Now let's move ahead. Uses of magnets. There are some important uses of magnets. Let's have a look. They are used in a compass to find directions. Definitely, we have seen magnetic compass. Then used in industries for lifting heavy masses of iron. Yes, in the scrap areas where a lot of iron scrap is there, to lift heavy damaged cars and vehicles, magnets are used because they get stuck. They can be pulled up easily. Used by surgeons in hospitals to remove steel splinters from the wound. जो लोग लोहे की चीज़ों से काम करते हैं, आयरन और स्टील के ऑब्जेक्ट्स बनाते हैं, कई बार उनको चोट लग जाती है एंड इवन दोज स्मॉल पीसेस गेट्स इनसाइड. कई बार एक्सीडेंट्स में भी ऐसा होता है. सो मैग्नेट्स आर यूज टू टेक देम आउट बिकॉज अदरवाइज उन्हें निकालने में बहुत पेन हो सकता है, काफ़ी ब्लड लॉस हो सकता है. सो सर्जन्स एंड डॉक्टर्स यूज सम मैग्नेटिक इंस्ट्रूमेंट्स टू टेक दोज पीसेज आउट. Used in construction of telephones, electric bells, etc. Used to separate iron and steel from non-magnetic materials. And many more uses which are unending because magnets are nowadays used in almost every field. They have a wide usage because of their different properties like attractive property, directive property. Then you have seen that poles always exist in pairs. Then repulsion is the sure test of magnetism. So they have a lot of usage and applications. Now, some action-packed info, guys, and trust me, it's very interesting and important. Let's have a look. Magnetized inks are used in checks. The checks which are used in banks, the checks which are connected, which are related with bank accounts, in those checks also magnetic ink is used. And why magnetic ink is used? Because that magnetic ink makes the checks accessible to machines. That means if a check is put up in an electronic machine, the machine can read it out, can identify the check, and those magnetic inks are mixed in a substance and then those substances are used for printing on the checks. Now I'll tell you where magnetic ink is used. If you are looking to the screen, you can see this word MICR line. Yes, this number. This 9-digit number which is present at the bottom in the center of the check on the white bar, that is MICR line, that is magnetic ink character recognition technology. With this MICR line, bank branch and the bank details are easily identified by the electronic devices and the payment and everything can be done. So that is why this is a very important usage of magnets, children, and a very technologically advanced usage, that magnetic inks are used in checks with this MICR line. For next time when you see a check of your parents, even tell them that this 9-digit number is MICR line, magnetic ink character recognition technology. Alright, let's move ahead. Demagnetization. Demagnetization means when magnets lose their properties because they are not kept properly, they are not handled properly, so they tend to lose their magnetism. And why it happens so? Heating a magnet to a very high temperature, when there is a lot of heat, magnets tend to lose their magnetic property. Sometimes due to hammering a magnet, that means continuously beating a magnet into pieces, it will lose its magnetism. Dropping a magnet from a very heighted place, it will lose its magnetism. Keeping a magnet close to other magnetic devices like cassettes, computers, television, it will lose its magnetism. So demagnetization means the tendency of a magnet to lose its magnetic strength, to lose its magnetism. Alright? And last but not the least, how to store a permanent magnet. Self-demagnetization means कुछ टाइम बाद हर मैग्नेट वीक होने लगता है. क्यों? क्योंकि उसके पोल्स खाली होते हैं, खुले होते हैं. That is self-demagnetization. In the last slide, you have seen demagnetization. When अलग-अलग reasons की वजह से magnets अपना magnetism या strength lose कर रहे थे. But कुछ टाइम बाद हर मैग्नेट में सेल्फ डीमैग्नेटाइजेशन देखा जाता है, यानी वो ऑटोमेटिकली खुद ही अपना मैग्नेटिक स्ट्रेंथ लूज करने लगते हैं, बिकॉज उनके जो दोनों पोल्स होते हैं नॉर्थ एंड साउथ, दे आर लेफ्ट ओपन, वैसे ही खुले होते हैं. So to prevent this self-demagnetization, magnets should be stored with magnetic keepers. Now these are magnetic keepers. Magnetic keepers comes in the shape of the magnets. Horseshoe magnet के लिए horseshoe magnetic keeper, bar magnet के लिए bar magnetic keeper. Now what is these magnetic keepers are? These magnetic keepers are having मैग्नेट एज वेल एज सॉफ्ट आयरन. एक साइड पे मैग्नेट लगा होता है, एक साइड पे सॉफ्ट आयरन लगा होता है, और बीच में आपको अपना मैग्नेट लगाना होता है. बट व्हाट इज द आइडिया अबाउट दिस? सपोज दिस इज अ बार मैग्नेट मैग्नेटिक कीपर. यहाँ पे मैग्नेट लगा होगा, यहाँ पे सॉफ्ट आयरन लगा होगा, एंड ओवर हेयर यू विल कीप योर ओन मैग्नेट. Now, if your own magnet's north pole is this side and south pole is this side, तो ये जो मैग्नेट है इसका साउथ पोल होगा इधर, इसका नॉर्थ पोल होगा इधर. इट इज ऑलवेज देयर. ये जिस पोल डायरेक्शन में लगा है, you will keep your own magnet in the opposite pole. That is how magnetic keepers are made. They always contain a soft iron piece and another magnet, because magnets are always kept in pairs in magnetic keepers. And the direction or the poles which are fixed in magnetic keepers, you will keep your own magnet in the opposite direction. अगर मैग्नेटिक कीपर का जो मैग्नेट है उसका यहाँ पे साउथ पोल है, तो आप अपने मैग्नेट का नॉर्थ पोल रखेंगे, जस्ट अपोजिट, and your magnet will not go for self demagnetization or demagnetization. Its magnetic strength will be saved out. Okay. Okay, my dear children, so this fun class today of Fun with Magnets has come to an end, and I'm sure that you all must have liked the video. So it's time for you to press the like button, and if you have still not subscribed to the EduCatUp YouTube channel, children, do it right now. Any doubts, any queries, anything you would like to ask me, and your valuable feedback, please put it up in the comment box below so that your super science teacher Ambika can get back to you. For me, it's time to sign out for the day. Until the time we meet again, be happy, be safe, keep having fun with magnets, and keep enriching yourself with EduCatUp. Thank you, children. Bye-bye.